In this video, I'm going to talk about how we can create a Venn diagram to organize information and answer questions when we're given information with three categories. So we have a Venn diagram with three different circles. So in this first example, you'll see here that it's all listed out in paragraph style. I actually prefer, and I know some students do as well, so I can show you what this looks like, and feel free to skip this if you want. But I like, as I read, to jot down the information in a list. To me, it's easier to put it in the Venn diagram. So 27 people at a park were surveyed about their pets. So that would be the total. I'm just going to say total is 27 people. Responses indicated that 19 had dogs, 10 had cats, and 5 had birds. So those are our three different categories there. So I'm just going to write down that information. So 19 had dogs, 10 had cats, and 5 have birds. Responses also indicated that 6 had both dogs and cats. So dogs and cats is 6. 4 had both dogs and birds. So dogs and birds is 4. And 1 had both cats and birds. So cats and birds, we have 1 person. And then there was 1 individual that had dogs, cats, and birds. So dogs, cats, and birds. So all 3, and that would be 1 person. So this is our all 3 number. All 3 categories or types of animals. So now that I have all this listed, I'm going to create my Venn diagram. And you can put 1 circle on the top, 2 on the bottom. You can do, 2 on the top and 1 on the bottom. It doesn't really matter. So I'm going to say that I'm going to draw my 3 circles, and I'm going to label them dogs, cats, and birds. Okay, and actually it might even be helpful to take my color that I used to underline, so we can use red for dogs, and then 10 for cat, or green for cats, and then birds is already blue. So we can really distinguish the difference between the circles. And so now I'm going to go through my list, and I'm going to ask myself, okay, what information, what number can I just put in the diagram? Are there any? Well, dogs, 19 dogs, that means this entire circle is 19, so I'm not going to be able to use that right away. Same with cats and birds, those numbers, because it's telling me the entire circle, which has multiple different parts, so I'm not ready to do those yet. One thing you do want to look out for is see if you're given an all 3 number, the intersection between all 3 categories, and in this problem we are. Sometimes you're not, but if you are, that's a good one to start with and put the 1 in the middle. And then I'm just going to check that off. And then I'm going to work my way backwards or up this list. So cats and birds is 1. So cats and birds, that'd be where the green and the blue overlap. So it'd be this section right here. And since I already have a 1 there, okay, if cats and birds is 1, that means nothing goes here, because there needs to be 1 total. So I'm just going to put a 0 there, and that way I have 1 total in the cat and bird intersection. And then the dogs and birds, so that would be where the red and the blue intersect, which is this sliver right here. And there's already a 1 in that part of the overlap, but if there should be 4 total, then I can do 4 minus 1 is 3. And so all together in where the dog and bird circles overlap, we do have 4. 3 here and 1 here. So 3 plus 1 is 4. And then working my way up the list. So dog and cat, the red circle and the green circle. It's this intersection right here. I already have a 1 there. So I'm going to have to subtract. I'm going to have to take the 6, which is my total for the dogs and cats combined, and then subtract the 1. And I get 5. And so the people that have dogs and cats, there's 6 of those, and so you can see here there's 5 here and 1 here, so there's 6 total. So now we can work up to our bigger numbers. So birds, the total number of people that have birds is 5, and so let's figure out what needs to go here. So if there are 5 total, but I already have 3 and 1 in the diagram, I'm going to take off 3 and I'm going to take off 1, and that gives me only 1 left. So there's 1 person that has a bird, but not a dog or cat. So that one's done. And then cats, let's figure out what needs to go here. So there are 10 total people that like or have a cat, and there are already 5 and 1, 5 plus 1 or 6 already in the circle. So I'm going to take 10 and I'm going to subtract 5 and subtract 1, the other numbers that are in the cat circle, and I'm going to get 4. And so 4 goes here. And it's really good to double check and make sure just by adding that when you add all of the numbers in the cat circle or any of the other numbers, it adds up to the total they give you. So 4 plus 5 plus 1, that gives you 10, and that's exactly what we should have for the cat circle. And then last with dogs, the dog total should be 19, but we already have a 5, a 1, and a 3 in that circle. So I'm going to take off the 5, I'm going to take off the 3, and I'm going to take off the 1, and that gives us 10. And so 10 here. And so when we add those up, 10 plus 5 plus 1 plus 3, we should get 19, which we do. So we're done with that circle. So now the only other part that we haven't labeled is the outside. So what goes in the outside? Well, we use the total. So there are 27 people total surveyed, and we're going to have to subtract all of the numbers in the picture, or you can add them all up. So this is what I would do. I would take my calculator and I would just start adding all of those numbers up. So I'd add 10 plus 5 plus 1 plus 3 plus 4, don't have to add the 0, plus 1. Okay, we add those all up and we get 24. So I'm going to take my total, which is 27, subtract 24, which is the total in the circles, and that gives me 3 that need to go on the outside. So there are 3 people that don't have cats, dogs, or birds. And so now that we have the Venn diagram done, now let's go and look at the question. So part A, how many people had only dogs? So if we're wondering how many people had only dogs, we're looking at just this 10 here, because the other numbers in the dog circle are part of the cat and the bird circle. So we only want this, this 10 here. And then how many had a dog and cat? So it's got to be in both circles, but not a bird. And so where do dogs and cat people intersect? Well, right here, but I don't want to take that 1 because see how that 1 is inside that blue bird circle? So 5 is going to be the number I need for cats and dogs, but not birds. Okay. Now cats or birds. So if we see the word or, that means one or the other or both. And so they could be in the cat circle, they could be in the bird circle, or they could be in the intersection. So I'm going to take every single number I see in the cat circle. So 4 plus 5 plus 1. And I'm going to add all the numbers in the bird circle. So 1 plus 3. I'm not going to add this 1 again though, because I already included that when I added up the cats. Okay, so we've got 9, 10, 11 plus 3 gives us 14. So that's 14 total. And then cats or dogs, but not both. Okay, so or, that means cat circle or dog circle, but we don't want both. So both is in the middle here. Okay, and so what we want to do is we want to find all of the numbers that are in the dog and cat circle, but we're not going to include this middle section here because that's where those are people that have dogs and cats, so both. So I'm going to add this 4, this 0, this 10, and this 3. So 4 plus 0, I'll just write it down so we know that we've at least looked at it, plus 3 plus 10, and then we get 17 for that one. And then the last one, none of these pets, and so we've already answered that by our, when we did our Venn diagram, because the 3 on the outside, it was a good thing that we found that number because that refers to the number of people that don't have any of these pets. So that answer is just 3. So you can see, doing the Venn diagram, I mean, it's a lot of work, but the nice thing is once you're asked questions, you can use your Venn diagram. It's really helpful and sometimes necessary to answer these questions. Sometimes like E, it can even make it easy because you've already really answered it by doing all the math and putting it in the diagram, and now you just have to, read the diagram. Okay, so let's do one more example. In this example, you can see we have the information nicely organized in a table, which is really helpful. And so we're going to draw a Venn diagram to start before we start answering any questions. And we have 3 different categories here. So we've got apples. I'll draw a circle and label it A. And then we have oranges. I'll put that up top, O. And then we have grapes. And we'll call this circle G. And so let's go ahead and look through this list and see if there are any numbers that I can just put right in the diagram. And we've learned from the last problem that, these bigger categories like all oranges, there are 13 kids that liked oranges. That can't go in the Venn diagram just yet because that's the total of all of the sections in the orange circle. So I'm going to go down the list and see if I can put any of these in. So apples and grapes, meaning it has to be in both circles, but not oranges. So apples and grapes would be this section right here, but we don't want to be in oranges. So that I can actually put right here. So those 4 kids fit right here in the Venn diagram. So apples and grapes, but not oranges. So outside of the orange circle. And then let's see, apples and grapes. So this whole entire intersection needs to be 7. So since there's already a 4 there, all I need to do here is do 7 minus 4, and that gives me 3. So there's going to be a 3 there. Okay, oranges and grapes. So oranges and grapes together, that would be this section. Well, I've already got a 3 in that section. So if that total needs to be 6, then I'm going to take off the 3 and I get 3. And so all together, there's 3 plus 3, which is 6 in the orange and grape intersection, which is what I want. And then the orange and apple intersection, which is right here, should have 8 total, and there's already a 3 there. So I'm going to take 8 minus 3, which gives me 5, and that's going to go in this section. Okay, now I'm going to move up to the bigger ones. So grape, I should have 20 all together in the circle. So to find what goes here, I'm going to take 20 and I'm going to subtract 3, and subtract 4, which are all of these numbers right here. And if I do that subtraction, I end up getting 10. And I can always reverse it by adding them up. 10 plus 3 is 13, plus 3 is 16, plus 4 is 20. And that's a good double check that, that I'm on the right track, because 20 is the number of kids that like grapes. And then last, we've got, well, not last actually, we've got 2 more. Apples should be 15. So let's figure out what needs to go here. So 15 total, but I'm going to take away the 5, the 3, and the 4, because they're already in the apple circle. And when I do that, I end up getting 3 left over. So the 3 is going to go there. And then the orange category, there should be 13 total kids that like oranges. So I'm going to take 13 and subtract the 5, the 3, and the 3. And when I do that, I end up getting 2. So we could double check 2 plus 5 plus 3 plus 3, and that gives us 13, which is what I should have for the total number of kids that like oranges. And then the only other one that I don't have yet would be the outside number. So if I want to find the number of kids that don't like oranges, apples, or grapes, then I could just look at the total, and it told me up here 35 kids in a summer camp. Sometimes it's sneaky and you got to read it up in the problem and not in the chart. So there are 35 kids total, and we can take off all of the numbers on the inside of the diagram. So let's go ahead and do that. So I'm going to grab my calculator since we have a lot of numbers here, and I'm going to just start adding up all the numbers in the picture. So 2 plus 5 plus 3 plus 3 plus 3 plus 4 plus 10. And just to double check, I'm going to count the numbers. So 1, 2, 3, 4, 5, 6, 7. And then I have 1, 2, 3, 4, 5, 6, 7 in my calculator. So I get 30 altogether. And we were told that there are 35 kids total. So I'm going to take 35, which is the grand total, and I'm going to subtract 30, which is the circle total, inside all the circles, and I get 5 kids that don't like any of those fruits. So now I'm done with the diagram. Now I can go up and answer the questions. So part A said, how many kids like only grapes? Well, only grapes is going to be these 10 students or 10 kids right here, because that's the only number that's not a part of the orange or apple circle. So only means don't include anybody who likes oranges or apples. So this one is going to be 10. For this next one, we want grapes or oranges, meaning it could be the G in the G circle or the orange, but not apples. So I'm going to look at any number that's either in the grape or orange circle, but I'm going to make sure not to include apples. So you can almost, if you wanted to, just take and cross this off, or you could use a piece of paper or take your hand and cover that up, since we don't want any apples, and you can see a little bit clearer that you want to take the 2, the 3, and the 10. So 2 plus 3 plus 10, and that gives us 15 total for that category. For C, we want how many kids like all 3. Well, that's a little bit easier because I'm looking at just the center of the diagram where all 3 circles intersect, so that's just 3. Okay, whoops, and I erased my 4. I'll put that back. Okay, the next one, how many kids like grapes and oranges but not apples? So and means it has to be in the grape and orange circle, but we cannot include apples. So it's similar to B. So I could start by just crossing off all of the apple numbers, okay, because we don't want apples. But and means that it's got to be in both grape and orange. So I'm just going to look at this 3 number right here, and that's the answer. Now compare that to B, where we said grapes or oranges. We counted the 2 and the 10 because or is a little looser. It means that it could, these kids, we could include kids that like oranges and not grapes, or grapes and not oranges. They don't have to like both. And then last question, how many kids like grapes or oranges or apples? And so that basically is the total of all of the circles. So you're looking at, all of the grape circle, all of the orange circle, all of the apple circle. So it's basically the total of all circles. So total of all circles. And it's a great thing that I showed my work down here, because we already calculated that. We found that the total of all circles is 30. So we could say 30. Another thing that we could have done is, knowing that there's 35 total, we could just take off the 5. So 35 minus 5 gives us 30 that needs to go, of kids that need to go on the inside of all the circles. So 30 kids like oranges, grapes, or apples. So 2 different ways you can do that, but it is nice, even though sometimes it looks a little messy or cluttered, but it is nice to show your work, so that way, if you need it later on when you're asked questions, you've got it and you don't have to recalculate.